Hey there, class. Today we are going to do yet another chemistry experiment. I know you come here every week for them, and we got them for you. Another chemistry experiment, and today we're going to talk a little bit about acids and bases, and we're going to borrow some ingredients from last week that are common household items. We're going to go back to the trusty vinegar and baking soda, but today we're going to have a much different effect, and I would encourage you that if you're not properly trained to maybe have your goggles, because we're going to get messy today, and if you don't have those, the towel will probably work just fine too. Anyway, we're going to take a bottle here, and I'm going to go ahead and kind of take this label off just so we can really get the full effect here. And what we're going to do today is we're going to take our baking soda, we're going to put it in a towel, and we're going to add some vinegar and kind of watch what happens. So the difference this week is we're not going to cap this. We're going to kind of let just nature kind of take its course here. So, and paper towel. I'm going to put some baking soda in here. Baking soda in here. I'm going to put it within our bottle. Let's see. Get it in there, okay. There we go. Got it in there. And what we're gonna do, this is where things are going to get a little bit messy. We're gonna add some vinegar and kind of watch what happens here. I'm gonna open this first. Okay, we're starting to see it here. You can kind of see the fizzing starting to happen. Our kind of not bath bomb, but our kind of baking soda bomb's kind of well insulated here. But as the vinegar continues to react, you're gonna get even more fizzing. Let's see if I swirl it around, if we'll get a little bit more in there. But what's taking place here is there's a chemical reaction. So we've got, oh, here we go. Here we go. And now we're making our eruption here. Now I've already got towels down, so we're good here. So what we have is we have a weak base, baking soda, followed by a weak base or a weak acid, our vinegar, which is also known as acetic acid. And when we combine the two, we have a reaction taking place where those two interact with each other, and if you remember from last week, CO2 is created. And so part of what's happening here is CO2 and this kind of narrow vessel is trying to escape. So it's part of what's taking place. Also, we have a carbonic acid is also being formed in a kind of separate reaction here. And carbonic acid by itself is kind of unstable alone at room temperatures here. So that quickly starts breaking down, and as we've kind of learned, carbonic acid, or when acid and base forms and they react together, a neutralization reaction takes place, and water is formed. So the principal thing that's happening again is the CO2 within a narrow vessel with kind of this paper towel kind of occluding things is causing the CO2 to try to find any way it can to escape. Now, the interesting fact about carbonic acid is that it actually exists within our blood. There's some more kind of science that goes along with that, but it plays a part in the transport of kind of gases within our blood being exchanged. But the difference is that we've got obviously a lot of different other proteins and chemicals and things like that to help kind of transport things. And there's actually an enzyme called carbonic anhydrase, which helps to kind of catalyze the reaction with that's involved with carbonic acid. So it's a little bit more stable, if you will, within our blood. So we definitely achieved the desired reaction here. Actually, you can still kind of tell there's still some fizzing taking place. I don't know if you can hear that or not. There's still some taking place there, as our paper towel has occluded the opening here, but we still have some fizzing going on right there. So I encourage you all to stay tuned for next week for our next chemistry experiment.